This is Tyler. I'm going to be teaching you just really quickly how to be lazy in your physics labs and use Microsoft Excel. I think the teachers enjoy it too because it's really nicely organized. Alright, so to begin with, there are a couple things that we need to know before we go ahead and analyze this video that I took of the actual experiment being done. My dog ended up getting the ball and taking it away afterwards for whatever reason, and he's pretty fast, so it took a few minutes to get it back from him. Oh well. We need to know the height that we dropped it from. In my case, I dropped it from the ceiling, and I understand that you can't quite see that in that video. That's about up here, right where the insert option is for Word. So that was about 8.5 feet, which translates roughly to 2.6 meters. Exact numbers aren't important right now. I'm just showing you how to use the Excel book with the data that you have. So secondly, we need to know the amount of time in each frame, 30 frames per second. And 1 over 30 frames, so that would be about 0.03 seconds per frame. So we're just taking this inverse here, right? So after that, we need to know how many frames it took for the ball to hit the ground, right? We're going to do a quick calculation and some dimensional analysis, which is actually done right down here. And we need to know how long that took. So let's go ahead and play that video. I'm going to count out the frames. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it looks like it took about 20 frames for the ball to fully hit the ground after I released it. So 0.03 seconds per frame times 20 frames, that's 0.6 seconds. And yes, I did watch this video beforehand. I did count it out, but I just wanted to show you so that I'm not making this up. It actually happened. Okay, so now that we have some of the initial information that we need to know, another thing that we need to include that should be given to us, and if it's not, you can look it up on Google, is your kinematics equation. So you know that distance is equal to, and considering that there's no initial velocity or displacement factor, we're only concerned with acceleration, that would be 1/2 at squared, and that comes from a very nice differential equation for those of you who didn't know that. Let's see if I can write this cleaner at all. Let's go ahead and go to insert. There should be a supertext option somewhere in here. Oh well, it's not important. So we can handle with the caret sign for squared. That's perfectly fine. And by the way, I'm going to put this in parentheses so you understand that that's 1/2 times at squared, not at squared, not 1 over 2 at squared. So, so that is that equation there. So let's go ahead and solve. Since we want to know acceleration, we're going to solve for acceleration. So we know that 2 times the distance is going to be equal to acceleration times time squared. Now acceleration is just going to be 2 times the distance divided by this, but divided by the time squared. So divided by the square of time. And actually this is very important as you get into your later physics and other mathematics life. This is called the inverse square law. So if we keep the distance constant, then the acceleration is going to decrease with the square of time. This is also applicable, for example, intensity. That's going to decrease with the square of distance. So this is the inverse square law. It is incredibly important. Make sure that you're very familiar with that. So now we're going to head on over to Microsoft Excel. And here in Excel, we're just going to plot out a couple of these basic information. So first of all, in Excel, I have this on another desktop. So in Excel, we're going to plot the time and we're going to plot that acceleration, or we're going to say, save that, so we're going to say acceleration. And oh yes, we need distance. I'm sorry. Let's go ahead and do distance first to make things a little bit easier in our calculation. Distance, time, and of course our final, I misspelled acceleration. So, and of course our final result that we want is acceleration. So let's go ahead and go over here to distance. Also, what I would recommend doing is in acceleration, make sure to include a note that says what formula you used for that. So acceleration is equal to what we said, 2 times the distance divided by the square of time. And your parentheses will hopefully take care of that nicely there. So now what we're going to do is we're going to go ahead and plot the distance. Well, the distance we already determined. That's 2.6 meters, right? And make sure, if you want, you can put the units. I'm not going to do that for right now. It's not really important for the sake of this video. But when it comes down to turning this into your teacher or whoever it's going to end up going to, professor in college, whatever it may be, make sure that you specify what units you're using, because it could be completely, you know, this could be feet, or this time could be years, whatever it may be. Make sure that you specify the units. For me right now, I'm using seconds, and seconds for time and meters for distance. So acceleration is going to end up being 2 times the distance, so 2 meters per second squared, right? Because we're squaring the time. We also apply that operator to the units as well. So our time was 0.6 seconds. So let's go ahead and head on back to our second desktop here and plug in 0.6 seconds. So now what we need to do is we need to input both of these cells of information, so cell 2A and 2B, into this equation. So we're going to take cell 2A, which has our distance, and cell 2B, which has our time, and we're going to plug that right in. So we're going to, in order to do that in Excel, you need to push equals, right? Equals, and make sure that your parentheses are well specified. So go ahead and put parentheses there. I know it looks like a frowny face, whatever. So it's going to be 2 times the distance, right? Divided by, and we're going to go ahead and plug in B2 and square that, and we should get an answer out here. I got 14.4. Obviously the acceleration, whoops, what am I doing? The acceleration of gravity is nowhere near that, but again, this is incredibly rough. I could have been totally off. The height to my ceiling was just an estimation, so yeah, that's another thing. Time also could be very sketchy. You know, I didn't get everything in correctly. So make sure that you repeat this a bunch of times with a bunch of different results, and you can calculate the acceleration very easily. So this is just one result. I could do another one. I'm going to make up these numbers here. Let's go ahead and go 3. So 3 meters, and we'll say, I don't know, 1 second. 1 second. So let's go ahead and just bring that down there. Okay, so there we get 6 meters per second. So, and again, this was totally made up in cell 3. So that's how you do that for Excel. The nice thing is if you have, so let's go ahead and go 4, 5, 6, 7, yada, yada, yada. And then we'll go 2, 3, 4, 5. Okay, so if we have this information, this formula that it wants us to use, we can just simply drag it down on all these cells, and it's going to apply the same operation to each of these cells that we inputted data for. And obviously once you're done, make sure you save it, print it out, turn it in, add more information up here. You can tinker with this as you like, but this is really just some of the most basic things to get it started. Anyways, I hope that helped those of you who are in first year physics or second or whatever physics class you're taking. It's really easy to use Excel. I love it. It's for the lazy math student. All you have to do is plug in your formula once and just drag it down, and it applies it to really everything. So all your data points. Make sure you do some work on paper first of all, though. Do some work on paper to determine what goes where, determine what your formula, what you might be applying to the data to get your output result. So make sure that you do some quick and easy, algebra on paper, if I may say, or calculus if you're in some of the more advanced physics, and then plug in that formula into Excel. And it's really super simple to apply it to any data points you may have. Again, specify your data in this formula up here as appropriate. Hope that helped. Always remember to save it. Before the video started, I actually had my computer crash on me, which I don't understand why, because I just installed 16 gigabytes of RAM on it. Anyways, make sure you save so that way if events like that do happen to you, you don't lose everything. I was lucky this document here was actually saved. Anyways, best of luck, and hope this helped. If you have any recommendations and you would like to see something else done in Excel, please leave a comment, direct message me, anything like that, and I will do as many examples as you need. Thank you. Bye-bye.